Hello, everyone. Here we would like to work on number 27 in 5.7. This is a numerical integration. We are asked to provide a trapezoid rule approximation whenever n equals to 6. First, let's write down the formula. And I simply draw pictures to illustrate the match point between x0 and xn. x0 will be the left endpoint, xn will be the right endpoint. In particular, whenever n equals to 6, we can draw a picture like this one, x0 equal to 1, x6 equal to 3. We can calculate delta x. So each subinterval, we can get the length equal to 1/3. All right. Now, we just write down the formula. Now, in each subinterval, we're gonna to add the function value at the right, left, and the right endpoint divided by 2. And then multiply by delta x, which is 1/3 in this case. Okay. Now we need to do a lot of function evaluations. There are some way to simplify it, but the most straightforward way is just to calculate term by term. We start from the definition, fx equal to e to the x. Now fx0 is just 1/e. fx1, x1 will be the second match point. So the distance between this one and the previous one is always 1/3. All right, so we actually know the value for x1, that will be 4/3. That's why fx1 will be e to the power of negative 4/3. Continue, we can calculate fx2 and also fx6. All right, we can calculate all of these, plug in. Right? Hopefully, there will not be too crazy calculations. Notice that we can still utilize the calculators for this homework. Okay, now plugging all these values, now most likely we will get an answer like this one, approximate 0.321. Okay, here, next I would like to mention the error bar. We do have a formula, measure the error between these, the exact value and the approximation. Now it seems that we have an upper bound to control it. We know almost every constant, b, a, n. Moreover, we have a number n. This is actually the largest second order derivative function over the interval a to b. Notice that we're going to take the absolute value of the second order derivative. Okay? Because fx equals e to the negative x, we can easily calculate the second order derivative. This is still e to the negative x or 1/e to the x. This is a decreasing function. Decreasing function, then we can easily obtain the upper bound like 1/e. So we could choose this m to be 1/e. Okay, now plugging. Now the right hand side will give us a number about 0.0068. What does this mean? So notice that 0.321, this is our numerical approximation. Now we go left hand side and the right hand side about 0.0068 units, then where actually we can cover, right? So this interval will cover the true solution. True solution is guaranteed to lie inside this interval. Okay. Indeed, this is not too difficult to calculate the exact value from this integration because the integrand is e to the negative x, right? Okay. So a straightforward calculation, we can find out the exact value will be 0.318. This is exactly inside our interval here. Okay, so this is why, other than the approximation formula, it's important to understand the error bar. Okay, so I believe this particular example will be sufficient for this section. Thanks for